Welcome to you all. We are waiting for some speakers to join in, and then we'll be starting at 7 p.m. IST. Today's session will be a second session of AG-104. So if you have not attended our last session, I will highly recommend you to watch the previous session recording, link posted in the comment. So, and also please go ahead and register for our next session if you have not. AG-104 will have total 8 sessions, of which second session is today's one. One is already done, and there will be 6 more sessions on this track. Each session will be having different topics, which covers the entire exam of AG-104. So if you cover all the sessions, then only you will get all the topic and all the things that is, all the concept that is required for giving this exam. So yeah, stay tuned. We will soon start the session. All right. So yeah, thank you again. Thanks for joining for today's session. And yeah, we have a really nice concepts to be covered today as a part of this exam track. And we have speakers, and I will introduce Neeraj. I will invite Neeraj to introduce to our speakers for today and the agenda for today. So Neeraj, can you please go ahead?
All right, thank you, Ashish, and I extend a warm welcome to all of you, and thank you for joining our session, especially on the weekend. Good morning, good afternoon, good evening, whichever part of the world you have joined in. We really appreciate all of you taking out time to join our session, especially for learning Azure. Now, this session that we are doing, it's for AZ-104, which is Azure Administrator Associate Certification Exam. And this is our second session today. As a part of this in past, it's an ongoing session. We have 8 sessions as a part of AZ-104. So the session 1 was covered last week. In case if you missed it, please do register on our website, or you can also go to our YouTube channel, which is youtube.com/c/Azure Talk, and that's where you will find the previous recording. So just quickly, we have started this initiative considering the COVID and coronavirus, because of that, a lot of people have lost job. So we as a team, as Azure Talk community team, we came together and we said what we can do to help people to reskill and find a job in cloud space. There are a lot of jobs opening in cloud, especially Azure. So that's when this idea came in. We all should come together and give back to our community. So we decided we are going to deliver training sessions to our community. Now, in case if you don't know about Azure Talk, so Azure Talk is an IM based community where people can go and ask questions about Azure. It's based on Telegram. So you have to install Telegram app. You can go and join that. There are more than 7,600 members, and members are very helpful. They answer questions, and some of our experts and some of our core team members also are there, and they respond to your questions. So we'll try to answer your questions during our sessions today, but in case you don't get answer, please do head out to our Azure Talk forum, join that on Telegram, and you can post your questions. That is very helpful community. I certainly encourage all of you to do join our Azure Talk forum. With that, I will move on to the next slide, and let me introduce you to my core team. So these are the team members, and it couldn't have been possible. We are doing these sessions, and it requires a lot of effort to put the content together and coordinate the effort. So I really it couldn't have been possible without this core team. So I'm Neeraj Kumar. I'm based out of US. I'm an MCT and enterprise architect. I have been in IT industry for almost 19 plus years. Then we have Ram Murthy. He's based out of Bangalore. He's MCT as well, and he works as an architect. We have Ashish Raj. You heard him. He opened the session. So Ashish Raj is again based out of Bangalore, and he's a DevOps architect. Then we have Vipin Jha. He is MCT trainer. He's based out of Delhi. And then today's speaker and Girish. So Girish is based out of Germany, and he has volunteered to do this session today. And then we have Lalit Rawat. So Lalit Rawat is Azure MVP from India region. He's also an MCT and architect. So this is our core team. Now, let me introduce you to the speaker who are going to lead us into the session. So today's speaker, uh, obviously, I will be your host, and and I'll be joined by Girish. So Girish is going to lead the session for us, and he will walk us through our compute session, which talks about Kubernetes and Azure Web App, and obviously we have agenda. I will not steal the thunder. I'll let Girish take over, and then we have Vipin. So Vipin and Girish are going to lead these sessions, and they will help walk us through all the entire content. So yeah, so with that, probably we can get into agenda, and I will hand over the baton to Girish. So Girish, please.
Sure, thanks, Niraj.
Welcome.
Yeah, hey guys. So welcome everyone. And today we will be going through a few of the topics from 104, and we have you can see these are the topics which we'll be covering as part of 104 certification program. And then the highlighted one, deploy and manage Azure Compute Service resources. This is 25 to 30%. It carries weight in the certification exam, and we are covering only the part 1 today, and part 2 would be covered soon, probably in the next weekend. And let's go ahead. Yes, today's agenda would be on a few of the Azure Compute Services like App Services, Containerization, and Container Registry, and Azure Container Instance. And then we will be focusing something on serverless computing as well. So yeah, so the prerequisite is if you know any of these below services, the compute services, which I would say as Azure Compute Services, that would be great. Any of this, either virtual machine, serverless computing, service fabric, VM scale sets, cloud services, or Azure Batch or Azure Container Services, any of this, then you must be knowing the life cycle of how exactly Azure Compute works, how do you monitor, how do you set alerts, and everything. So, but if you don't know, there's no worries. We will try to explain you. Let's go ahead and let's deep dive into the app services. So app services is again an offering from Azure, and it's basically a PaaS offering specifically for web apps, where you can actually host your application, and then you can actually log into or has SSH into it, and then to find the logs only for reading the application related logs. Also, you can do it. If you take an example of app service constitute of a lot of different services. It includes web apps, logic apps, and function apps, API apps, and mobile apps. So each of these particular apps have been designed to meet up on the customer workload, which are very different in nature. So web apps can be chosen for people who just want to host their website onto the cloud and meet their scaling demand, and use them to cater to the global customers. And logic apps are nothing but where you do not need code to write, but you can integrate a lot of heterogeneous systems. And function apps are a lot of serverless computing a service which you get from Azure, and we will go deep onto each of these particular services by in the next few slides. And we do have mobile apps for basically build for mobile platforms and emulators, and API apps are again and for hosting your APIs. So let's define what exactly is app service. So, and then if you go inside it, so it enables you to build your app and host your web apps. And then you can build a lot of REST APIs using any of the programming languages, irrespective of whether you have wrote your existing REST APIs into any program like in Java or in .NET or in Python, anything. Azure App Service supports each and every language. And then you do not need to manage infrastructure, which means that developer is now free from all of the overhead of managing infrastructure. Like if he need to write a specific app, or if you need to write or host a specific website or expose some APIs, he was actually responsible to host them and then manage them and monitor them likewise. But now with app services, you have a lot of abstraction, and you just a developer just can can focus on his logic, on his development, or on giving out the features to his customers, rather than leveraging the power of cloud, and also abstracting this management and operations tasks to Azure itself. And then it's offers a lot of auto scaling features and high availability, and we'll know what exactly is scaling if you don't know, and availability also we'll talk about. And then yes, it supports both Windows and Linux. So if you have current your applications which are running, and you have a runtime which your application runtime which is only supported on Windows or Linux, yes, you can go ahead and provision any of this particular operating system as a host to support your particular application. And yes, it inbuilt gets with CI/CD CI/CD integration solution, and you have all automated deployments you can do. Whether you can integrate, you want to integrate from GitHub, you want to integrate from Azure DevOps or any Git repo. And then you have serverless code, which is basically covers Azure functions, and which says about like you do not have an underlying machine which is running to execute your code. And yes, app services have different offerings, like app services environment, which actually offer you a lot of security and compliances. And yes, you can integrate with your current government clouds as well, whether it's German government cloud or China Go cloud, or any other Go clouds it's supported. Let's go ahead. App services, if you take from a broader view, so it's a fully managed platform, and Azure take care of maintaining the patches, the updates, the security, and the scaling, the auto scaling. Basically, when I talk about everything for you, and you just need to host your applications. And it does come, as I said, like it does come with CI/CD integration, a built-in CI/CD integration, and which using the concepts of deployment slots, you can actually maintain zero downtime deployment. Then you have app service environment, which is very specific to make your particular applications to be isolated from outside world or from the public, and to securely host your application. And yes, as I've already said, security and compliances are are adhered rigorously in app service, which you can take benefit of. And if I go and explain what exactly is app service plan, because every app services need to be embedded with an app service plan. So app service plan, if I explain, it's like a ship, and every ship has a at some point of time has a limit, right? It can't actually accommodate more number of goods or containers than it can do it, right? So you can imagine the app service plan is a ship, or app service plan is a sort of the number of virtual machine instances, or just the size of your CPU. It's like your own server rack. Okay, on top of that, you're trying to put your app service, which is nothing but it can be your any API app, or it can be your web app, anything. Okay, and you're trying to load that particular onto the app service plan. Okay, and then what happens, like there's a limit for everything. You can't actually load more web apps than the actual server limit, right? Because you can't actually load more number of containers than the ship can accommodate, right? So that's what is app service plan. And yes, every app service plan has a limit, and which is tightly bound with the number of VM instances currently running for that app service plan, or the size of CPU. In fact, what I can say is like what sort of plan you have opted for. So if you go for plans, so there are various plans with the app services. You can, if you're trying out something, if you want to just go with a free app service plan, you are welcome. And the way you get to host your web, mobile, or API apps up to 10 in numbers. Because 10 in numbers, because they will have an unique URLs for each of the API apps which you're gonna host. Okay, and the disk space for storing your secondary files related to applications would be 1 GB. And you can't take benefit of custom domains, you can't auto scale, you can't do Vipin hybrid connectivity with it, and network isolation isn't possible with a free tier app service plan. But if you go with shared, so you get 100 app services to be host. You can host, and the disk space is 1 GB, and it supports custom domain. Okay. And what happens with this particular shared plan is like you have application, and it would be hosted with some other particular applications or from some other customers. You wouldn't know, or you cannot debug into their logs, but you all would be landed onto the same host machine, which is basically the CPU is getting shared within each of you. So that is one thing with shared. You do not have an isolated environment for that. You share resources from the other parties, but yeah, make sure like you get a fair usage of your resources when you are on a shared plan. And like apart from this, we have something called as basic, standard, premium, and isolated, and each vary with the amount of disk space they give. And they have in common is like you can host unlimited amount of apps. But think that if you have an app which is consuming all of the 10 GB of data and taking right amount of fair usage of network and everything, then you have a limit. You can't actually cross through. So and then like if you go through the custom domain and auto scale, once you move more into the isolated, you have support for network isolation and VPN connectivities. Obviously, a hybrid connectivity will also be there because you would be hosting your workload on your on-premise, not on the public totally. So that is a benefit of being or hosting your solution isolated inside your network, and then still be able to use the power of cloud. Going ahead, so we said like scaling, right? Scaling is sort of a particular parameter which enhances your particular applications or instances to scale up to meet the demand of upcoming request to the request which you are getting it. So and scaling is like in simple words, what I can say is like if you take an example of scale up, you have a virtual machine with basic series B series VM, and everything is fine. You are running your application and everything is OK. And then suddenly you get a burst of traffic. At that time, you think that OK, let me increase my size of this particular machine on which I'm hosting my application. What you're going to do is like you're going to switch off this machine and get another machine. Or what you're going to do, like if it has a 1 gig of memory, you would bring extra 3 gigs of memory, you stop your machine, you insert the 3 gigs of memory, and then you boot up your machine. Okay, so that's what is scale up, where you are actually increasing the size or the disk space or the secondary memory of your particular box, machine or instance, you can say, and then you scale up according to the demand which you're getting it. Okay, but scale up is more of pre-planned than it happens on the fly. I will say the reason why you do not go with on the fly when you want to do a scale up. And when scaling out is an option where you don't want to go for a downtime, and you have a B series VM, probably take it up as an example as 1 gig of RAM, and you want to just add, you have another B series, a few more B series VMs or the machines with you. So you just club them and then give this as a complete workload to your app service. So this is one option which is called a scale out, where you are not increasing the size of size of the machine, but rather what you're doing is you are actually adding more number of servers to your existing workload. So that is scale out. And there's a problem with scale up, which I've said,
So
like,
yes.
yep,
So Chris, if I can add one point.
yes.
So, the recommended solution and from cloud provider is a scale up or scale out, and why would someone choose one versus another, right?
Yes, yes. So scale up is good because you do not need to maintain, or Azure is not going to maintain much of this service, right? But think of a scenario like you have an application request which is already getting processed, like you have a Flipkart application, something like this, or in an e-commerce application where the session is active and a user is manipulating and he is using the application, and when you scale up, it actually restarts your machine. Okay, which means that the existing connections will be terminated, and you should the application logic should have a retry method to setting up a new session when the server comes up. So that's one particular problem where we do not suggest to the customers to go with scale up rather than try to scale out. And it's only in the pre-planned cases we can go with scale up, and that is very much advised. Hope I answered your question, Neeraj.
Yeah, thank you.
Yeah, sure. Okay. So that's what, as Neeraj asked, let me show a few more pointers with scale up. Is like it would cause interruption. As I said, like, if there is an active sessions with your server, then they would be interrupted because the server will go under restart when you scale up. Okay, but with scale out, it's a different case because it would load level your request from that particular session to from that particular box to another box, and it does a rolling upgrade, not directly or rolling restart, not exactly, it restarts all of the instances. So that is one thing. So interruption in services, you should not go with scale up. And uh, uh, and and then yes, the client apps which got disconnected during the active session which we had, they need to reconnect, which means that you need to maintain your session somewhere in Outlook server, in SQL or somewhere else, and you need to take that particular session and then make your particular client request reconnect back to the application onto the new server, and then maintain the same state so that user never feels that he was disconnected for a moment. And um, and new connections might be rejected until the scaling finishes. So the old connections can be maintained, but the new connections, yes, they will be rejected until unless the server comes up and gives out the 200 OK to the application, to the client apps, in fact. And scaling up can cause, yes, if you have certain web firewalls, like you have some, if you're using the app service environment where you will have chances of maintaining your particular IPs whitelisted in your firewall, in your organization firewall. So think of a scenario like you scaled up your particular app service environment. Now the IP of it, basically the outgoing IP address of it will change. Okay, and if it changes, you actually need to update the new IP address with your on-premise firewall. So that is one particular another issue which I want to make it and show it up here.
So
And then, yeah.
I think one issue probably we all can face is when you go scale up versus scale out, right? Scale up has a limit, a physical limit. You can go up to certain level of VMSQ, maybe, you can go up to 64 GB of RAM or 128 GB. But if you require more processing power, you will hit the limit, right? But if you do the scale out, it's kind of infinite. It will depend on, what's the capacity in that data center of Microsoft Azure. But scale out certainly has a benefit is obviously you will not have any service interruption. At the same time, you can overcome the physical limit of single box. Remember, scale up is you're adding more resources in single box, right? If you do the scale out, then you can have resources capacity which is theoretically unlimited. right? There is no
Yeah,
limit. You can keep adding number of servers. You can.
yeah.
So that's another, I think, probably a favorable point why, cloud providers, in fact, all cloud providers, including Azure, encourages customers to use scale out strategy versus scale up strategy.
Mhm. I would like to add one point there. In scale out would work great, as Neeraj said. But again, if you're using app service environment, which is tightly bound with your VNet, so your VNet has certain limitations. Like if you are using IPv4 addresses, then there may be a limit. So that can be one particular factor. But do research before you implement, even scale out as well. Okay. Okay. Moving forward. Yeah, so this is a question from last of whatever we gone through the last slides. So the question is, can I choose between Windows or Linux OS as a host in my app service? Let me know your answers. You can vote your answers on this particular URL. Go to this URL or just scan this particular QR code, and we will have analysis of your results.
So you can go to azureeasy.com/Q1 and cast your vote there. Choose your answers there. Or you can also scan the QR code, as Girish said, and probably you'll also find the link in the chat in the Q&A. Post this.
Yes, people are answering. Let me switch to another screen. Let's see how many of you guys are correct. Switch back to my slides. And the answer is true. Most of you guys are correct. And with this, let's proceed with our next. So you saw it, lab services does a lot of work for you, but you can't put up all of your workloads into the app services. So and the world is going towards containerization, and we will go and take you through what exactly is containerization is. And if when we talk about containerization, it's mostly about Docker containers and the Docker setup completely. You would remember. So you have a complete Docker architecture where you will be having a Docker client installed on your laptop, and then you have application code which is sitting in your laptop or in your machine, and then you package them, and then you make a image out of it. So you use Docker, you make an image out of it, and then you build that particular code, and then once the image is generated, you can actually have a flexibility to push this particular image onto. So basically, when I say about image, it's Docker image. Even you can test this particular Docker image, but is whether it would work fine at runtime. You can actually trigger a Docker run command on your Docker client. It would run container, and you can see the application which is running. And that is one way of checking in local before you actually push your image onto the Docker hub or onto your own private registry. Okay, and since many years back, a few years back, we used to have, we didn't have any private repository concepts, and at that time, each and every enterprise organization used to have their own Docker Hub account, a private Docker Hub account, and then they used to maintain their own particular images which they have built, and because they wanted to implement more of containerization solution, because it was independent of whatever host underlying it. So that's where people started pushing, the enterprise started pushing onto Docker Hub, but people started realizing more on the security and other perspective, which we're going to discuss. So what exactly is a container? And specific is it's just a portable unit of deployment. Um, and which packs the inside your physical virtual machine. If you have contains nothing but it would have your product code, the actual core code, and its own libraries. If it has any dependency libraries, something like that, it would have, and it would also have the runtime to run this particular complete product or complete application itself. And this all packaged into a container. Okay, and when it runs on a physical machine, it runs as a container and provides you a service. So virtualization, uh, so with containers, what you can do is like you can use a single part of the single physical virtual machine to host multiple number of containers instead of the old traditional method where you used to hardly maintain one or two applications for a VM in order to have a consistency, and there may be a problem of isolation of application if they're not belong to a single team, because you need to maintain the secrecy between the secrets, certificates, everything stored on that particular machine. So what you can do with containerization is like you can slice up your OS to run multiple apps, and each container can now will have an isolated environment, but actually it's going to share the same kernel, and it would have, each container would be having its service running, and each container and app actually shares the same lifecycle. And if you go to an example like how exactly we implement in the day-to-day life, you will have a Docker image file which would describe about your application, and which would say that like which particular .NET, it's a .NET app and it need to be run on a .NET runtime. And then after that, where does, after successful build, after the build, how you gonna actually publish it and make an image out of it. So you have a Docker file, and Docker file says everything about an application and environment. And then you run a Docker build command. It would create a Docker image, and then you run Docker run. Then it would spin up instances of that particular applications as a part of containers. And then why, what was the importance of Docker? Like then life before Docker was like we were having a single machine where we were hosting our applications, right? So the environment, setting up environment of VM is expensive, right? Because if you take if a developer comes to a project, then if you are setting his laptop, then a developer need to first set up his all his environment to just run his application, right? So you need to install, configure, you need to set environment variables. In fact, you need to install all the dependent softwares, and then the same you need to repeat with your test server and also with the live or the prod server as well. So those were the issues before Docker, and with Docker you actually can remove a lot of this particular problems of dependency issues. It works on my machine, why doesn't work on your machine, and versioning issues with the DLL version issues you can remove, and configurations if you have inconsistent configurations, earlier that was a problem, but here it isn't, because everything is packed together, and the run times are always updated, or it's the same across all the environments. So that is one benefit. And if you take if you compare physically, like how exactly it would look, is like you have a VM, and basically that may be running your Windows or Linux or Mac OS, and on top of that you have Hyper-V installed on it. And this is the same, the basic approach with the VMS, virtual machines. And on top of hypervisor, you have various guest OSs. And for every individual applications, you will have a specific guest OSs, because maybe you have specific configurations for the application to run, environment variables or settings which are specific to run. That's what you will have, and you will have the specific binaries and libraries which are very specific to applications on top of it. So you can see like on top of your host OS, you're maintaining guest OSs here, and then obviously licenses are required for them. And then if you take an example of more onto the containerization aspect, then you do not need to have guest OSs on top of your host OS. You can run directly anything like a Docker engine, Docker C, Community Edition you can take and run, and then that particular client would help you in virtualizing your particular application, where you just need to give your binary sub libraries of that particular application, and it is good to go. And so you are decreasing a lot of overhead here, and obviously the power consumption and other thing is also a concern which is getting saved. And life with Docker was easy a little bit, but not for the production workloads. You can see this is a complete port, and the port has a ship where it's loading up certain containers. Okay, and just think that how you would manage, how would be, it would be really difficult to manage those many of containers in at live. Okay, so similarly, so applications were running fine with Docker images building up, and then each applications were coming with their own Docker images, and then they were publishing and pushing onto the production. But managing the life cycle of those particular containers onto the production was a very big headache, and it wasn't easy to manage. So that's where we had something. So we like world wanted a solution of orchestration, which can take care of managing all these containers lying around here and there. And if we go through container orchestration, it would say.
Yeah, Girish, just
Yeah.
I mean, before we jump into the container
Okay.
orchestration, I just
Yeah.
want to give a thing here that why how you should relate the Docker thing with the all these things going on around about Kubernetes, right? So what happened, as Girish has said, Docker was giving you the flexibility of creating small chunks. Now when you are able to create small chunks, definitely it gives you the flexibility in terms of all those server density or resource utilization and all those kind of benefits. But at the same time you get the problem where you have so many small things. Now you need to manage all these small things, and these small things can be interconnected, and that's what this image, what Girish is showing, represents. So you have a shipyard, right, and lot many small containers are coming through different ships, and then there has to be someone who should be able to control this traffic. If not, it will happen, then what will happen, nobody knows where to go, where to stop, where to connect, and all those kind of information, and things will start breaking up. And that's what start happening when Docker was not able to meet this requirement. As much people were expecting. People were creating a lot of Docker things. They were separate. People were having a lot of issues when they wanted to connect each other, so that during this all crowd they should not have a lot of work have to do. I mean, a lot of custom work to say, script and all, connecting them each other, discovering each other. And that's when the orchestrator came into the picture, which Girish is soon going to introduce. So orchestrator is someone like your traffic, your traffic signal manager, or someone who sits in between, who has authority, who can control who can go where, who can do what, who needs to be stopped, who can be, resumed, and all kind of stuff. So that's what the Docker and Kubernetes connect with. So Docker and Kubernetes are not parallelly working together. I mean, they are something, Kubernetes is on top of Docker. You need to have the Docker when you start working with Kubernetes. So Docker is already there. You need to manage the Docker efficiently. That's when you need Kubernetes or any orchestrator engine. So yeah, Girish, please. Yeah, thank you.
Yes. Yeah. Yeah, so in order to make life easy, the world wanted to have a solution which can help them to manage these all things. And then the container orchestration came, and they have been delivered with certain features like, it can schedule, provision container instances on the fly. It can scale, like add or remove instances to meet demand, like whenever there is a requirement, like more number of requests are coming, it would auto scale, and when there is very less demand, it would downscale itself. And then there was also, the cases of affinity, like where particularly your instance is gonna be, gonna be run. Okay, obviously it's gonna be running on certain host. Okay, you need to be mentioning or orchestration tool. It should have the capability of setting up the applications nearby if they are the homogeneous, like if they are of same nature, of same team, they should be on the same place. And if they're heterogeneous, then they can be placed on a different place. If you have selected some availability or something like that, then anti-affinity will come, where they would be hosted on a few different geographical regions. And networking, yes, because once you run containers, and then the IP allocations, everything need to be taken care. So there should be one particular system which can do this virtual networking on the fly. And then health monitoring is also concerned, because the orchestration tool needs to detect if every particular container which was supposed to be run are running fine or not. If they are killed, then what exactly, whether the orchestration tool can self heal and bring back those particular containers or not. And then service discovery, it relates to more of containers to locate each other, because if one particular in fact one application want to talk to another application, there should be a connectivity between them, or it need to discover the other service, right, which is hosted on the same infra. And then failover, it's like whenever something bad happens, then what is the DR strategy, like how exactly the orchestration tool gonna fail over the running instances to another good machine where it can run. And coordinated upgrades would talk more about, because underlying systems are virtual machines only ultimately, and they need to go under regular patch updates. So that need to be taken care. And And so we'll be talking about more orchestration tool further in the Kubernetes module, and we'll learn about Azure Container Registry. So Azure Container Registry is very similar to Docker Hub or Docker Hub Registry, but what I can say is like Azure Container Registry gives you more features what Docker Hub used to give for an enterprise level solutions. So you can see you create image, you push onto Docker Hub, and then you run those particular Docker image from the Docker Hub on Azure Container Services, or on Amazon, on EKS, or on Oracle Cloud Services. So it's independent of any of the cloud vendors. You could post your solution. So, and with respect to when we talk about Azure Container Registry, we also need to talk about Azure Container Registry tasks, which actually gives an inbuilt capability of integrating your particular registry, which means that repository of your Docker image with a lot of source repos, like from Docker Hub or Container Registry, or from source repository like GitHub or Azure DevOps, anything. Okay, so what happens is like whenever your code, whenever someone checks in your commits the code into your repository, then Azure Container Registry task, which is also known as build task earlier, will actually grab that information, and using webhooks, actually it would trigger a build when it sees a new code was committed. Okay, and then the image will be built. The image will be built, and then that would be built, which will be built using this particular triggers concept, and then it would be pushed onto Azure Container Registry. So always it's an automated. So whatever your latest code is there, you will have a latest image out of it onto your Azure Container Registry. You can set this up, and during our lab sessions, we're gonna do that. And then if we go further, then security is the one aspect which actually makes Azure Container Registry very different from the Docker Hub. It has very granular control, like it uses role-based access control from Azure Active Directory, which is inbuilt feature from Azure itself. You can use it to who can access your registry, who can access your image, and who cannot. And now the images can be signed in, so that you can protect from any untrusted parties. Like if any particular tools or any particular clients are there who are trying to overwrite your image with their own corrupt image or something like that, you can actually use you can sign your particular images, so that one need to sign the images before they actually can overwrite your image. And then images are encrypted at rest, so you can be worry free. And Azure Container Instance gives you a solution of more of running your particular image, which you have dumped onto the Azure Container Registry in few seconds. OK, so you do not need to configure anything for that. There's just a one-time configuration and it's all done. And it provides you fast startup. You can launch containers in seconds, and it works on per second billing basis. And the amount of time your container is running, then only you will be charged. And you have an hypervisor level security, and because it also has an application isolation completely. But it's sort of if you're running your application on a VM, it's similar to that experience. And the custom sizes you can mention using CPU cores and memory. And persistent storage are what I can say is like sort of storages which your application can use to write the state of your application, something like that. OK, and these are sort of disks only, and we call it as persistent volumes as well. And you can use something called as Azure File Share to do it. You can tag your Azure File Share and your application can create the persistent storage underneath them. And that is one benefit. And yes, you can choose Linux or Windows according to your, you can trigger any of use any of this Linux or Windows containers using the same API. You do not need to trigger a different APIs to run your Linux workloads. And the basic example of Azure Container Instance where I can use is like where I have a very specific task, like I have an automation or a build task, which actually, or a patch update task, which actually would be very constant, will not be very dynamic in nature. And I'll be using in such scenarios a solution of Azure Container Instance and Azure Container Registry. And AC limitations are there, and scenarios where it may not help you is like, where you need to do service discovery for across all of your multiple containers which are running. You don't have that capability with Azure Container Instance, and automatic scaling of these instances is not possible. And application upgrades coordinated, which is like rolling upgrade, isn't possible. So let's go with this. Let's go with the other question. So where can I store or maintain my public Docker images? Is it Azure Container Registry or is it a Docker Hub? Please go to this particular URL or scan this QR code and answer. I'll be checking the result. Show up the question again. Where can I store or maintain my public Docker images? Is it Azure Container Registry or Docker Hub? Let's see the results.
This will be available after 1 minute.
Yeah.
As soon as
sure. Yeah, I'll keep refreshing it.
Yeah, just give a couple of minutes for people.
Yeah.
Yep. So we have the results.
Yeah. So we have the results. So it's looks like to a draw. Yeah. So let's check the answer. So the answer is Docker Hub, because I said my public Docker images, like it's not private to my to any of my environment, or I don't want to use in my enterprise account or enterprise projects, right? So obviously in those cases where you want to share your application with others to improvise and then add like community sort of images can be pushed onto Docker Hub, and that's what I was asking for. Thank you for the answers. And let's go with the other question. Azure Container Instances bills customers on per second billing basis. Is the statement true or false? I'll repeat again. Azure Container Instances bills customer on per second billing basis. Is a statement true or false? Similarly, you can go to this URL or scan the QR code to answer it. Let me check the results. It needs some more time, I think. Go through the answer, go through the question and answer if you have not yet answered it.
So we have the results now.
Okay, thanks, Ashish. Yep. Okay, so the answer is true, and most of you guys are correct. And let's proceed ahead with Kubernetes services. We were long awaiting for this particular thing, and it's again orchestrated tool, which I would say, and it has become as a de facto a standard, or it's a new normal sort of standard or must standard, which is used across all container orchestration systems. So when you say about orchestrator, people usually talk about Kubernetes. And then it's for all cloud native world, it is becoming the operating system, because irrespective of any of the cloud vendors, you can actually use Kubernetes anywhere and everywhere. And it helps you in automating your deployments, scaling, auto scaling, and then if you mention replica sets and operational issues, maintenance, and patch updates, other thing, everything is has been taken care by this particular orchestrated tool, which is Kubernetes, which in short we call as K8s as well. And it handles a lot of your all of your continuous workloads across all of the clusters which you spin and across your hosts.
So Girish, probably what we can do is we can try to go at an easy pace. People are trying to still, because there is a lag, so maybe we can go a little bit easy on the pace.
Okay.
And
Sure.
yeah, so some
Sure.
people are having.
Sure. Thanks. Yeah, so when you go towards into understanding more of Azure Kubernetes services, so Kubernetes has been used by a lot of different cloud vendors, and one particular service offering from Azure is Azure Kubernetes Service, and it's sort of fully managed Kubernetes platform and hosted in Azure, and it's given as a PaaS service. And it's deeply integrated with all of the Azure Dev tools. It's very well integrated with Azure DevOps as well, and many of the other services. You can directly use your Azure Kubernetes services with them. And then it actually decreases a lot of complexity and overhead, operational overhead, like the patching, the node management, and security concerns. Everything has been taken care by Azure Kubernetes services for managing your Kubernetes workload. And at no extra charges, it helps you in a lot of things, like it has a capability of self-healing. It has good monitoring system, and which has a good integration with log analytics, and you have a good retention of your logs for 90 days. And you have the auto scaling features, and you can use something called as VM skill set for your AKS as an under hood node management. And then the availability and high reliability is also ensured, because you can choose something called as availability zones with the Azure Kubernetes services. And going ahead, so what exactly is a Kubernetes cluster? So Kubernetes cluster is sort of an orchestrator with support cluster based technology. And when I say about cluster, is nothing but it's pool of virtual machines or nodes. Like it's like you have bunch of virtual machines you bring up together, and then you try to use cluster them as a pool, and you call it as cluster. And then they are very highly available environment for, because of many of the reasons which you will discover in further slides. And they can scale from 0 to 100 in few seconds. And if you have a workload, you can think like if you have a workload which gonna receive huge traffic, like it's a Christmas Eve, or it's any other festival. At that time you will have a boom of traffic, and you do not want to worry about scaling by yourself manually. So you can use something called as VM scale sets with your Kubernetes on AKS, and which can scale, bring down your environment to 0, and it can take you to the hundreds or thousands basing upon your subscription. And
Okay,
then
yeah, Girish,
yeah,
just one
yeah.
moment. Let me just go back and let me just relate certain things.
Okay.
Okay, so what we have discussed so far is that you have Docker, you can create your container using, as Girish has rightly explained, that you have a Docker file, you create Docker container, and then we discussed that how when you have so many containers, you need a traffic manager or someone, I would not use traffic manager because that's a different technical term, but yeah, in essence that you need someone who can control all these all these mess or all these crowd of container for you, because if you want to control it, you have to do a lot of work to make it happen because you have small chunks of people. Now then only we actually introduced the concept of orchestrator, and now Kubernetes is coming up as a one of the de facto container orchestrator, which can take up your work of controlling all these containers and can help you in maintaining all these connectivity or whatever work you need for day to day managing all these small chunks of container, because they are very lightweight. Yeah, they are lightweight, but at the same time they are very small things and they are moving here and there, and you need to maintain who can go where, who can access what, and how, what are the resources, who can get what resources and all. That's what Kubernetes can do. But now what you can see, Kubernetes cluster. So you are seeing that you need a cluster of a maintainer to maintain a already set up cluster of containers. So it is like, it is making up like a inception kind of thing, right? So you have lot many containers, you want someone to control it, and now you want that guy to have a cluster. Why you need it? Because what happens when you have so much traffic, when you have so many containers and you have someone to maintain it, and you need to make sure that someone is also highly available, because if somehow that someone, that controller goes down, your all the things which are being maintained or being controlled by that someone will be nowhere to look around. What are the rules, where what? So that's what, that's why you need Kubernetes cluster. You need to make sure it is highly available, and that's when AKS comes into the picture. And Girish will take it, Girish will explain what are the different options you have in AKS that makes it a very valid candidate for make a Kubernetes cluster which is highly available. Kubernetes, as you guys may know, you can create on your laptop as well, but it might not be a highly available solution. And in the production, you need it. Why you need it? Because that is the person who is controlling the whole thing, and you need someone responsible who can control all these things. So that's when, these all managed services like AKS and all comes into the picture. And that's when, Girish is going to explain what are the different things that AKS gives you apart from a very normal Kubernetes cluster. Yeah, Girish, can you please go
Yeah.
ahead? Yeah, thank you.
Yeah. Thanks for adding the points. And yes, so the nodes can be heterogeneous, as Ashish said, like you will have its own hardware. The cluster itself has an hardware or homogeneous systems which need to be which need to make the cluster itself highly available, right? So the nodes inside this particular clusters are heterogeneous. Okay, when I say heterogeneous, it's more about size related. So you can have a graphic intensive or graphic oriented CPUs as well as part of nodes or node pools. You can have a basic series VM as part of node pools. You can have something as a memory intensive workloads as well, because it's every application is of sort of different nature, right? So they may require different nature of hardware underlying it. So you can use such systems in the cluster itself, Kubernetes cluster. And good thing is, like, each nodes are aware about each other in here when you use Kubernetes. And how exactly you want to provision your first AKS cluster is using Azure Portal, or you can use Azure CLI, or you can simply run an Azure ARM script via your PowerShell, or even and then we will be taking you through the lab where we would be explaining these series of steps. And if you talk about more about on the AKS cluster architecture, so there are two components of AKS cluster architecture. One is Azure managed, the components which are managed by Azure, and the components which are managed by customer. And so the master node, the master nodes you have nodes which are managed by you, and the master nodes is entirely managed by Azure, and which is responsible for managing the entire cluster itself. And then you have something called as APS server, and APS service is responsible for all of the REST commands to master node. Basically, when you run a kubectl command via which you interact with an AKS cluster, so a Kubernetes cluster. So the first series of steps, or whatever the REST API calls you're making to the commands you're running, it would actually hit the APS server. And then you have something called as etcd database, and this is a sort of a key value data store which maintains a cluster state at any point of time. And you have controller manager, which take care of the namespaces which you create in the cluster, the replications which you create of pods, and it also handles many of the routine jobs, routine tasks in the clusters. And then kubeproxy is the one which is responsible for all the virtual networking. Like, you have nodes, very good. Your node has an IP, even good. But again, you would be running some instances inside your particular nodes, right? So they also need to be tagged with IP addresses. So kubeproxy takes care of doing that particular virtual networking and handle the traffic. And then you have something called as container runtime, and it allows container applications to run and interact with a lot of different Azure services like virtual network storage, or even with the other containers with other particular services which are running inside the node. And this kubelet is one particular component which actually monitors all the nodes and pods which are actively running, and it maintains the state of them. And scheduler is the one component which actually deploys containers across the cluster. So, and then kubectl is the command, is the command line utility which you use to interact with the AKS cluster. And with you just using kubectl, you can manage the complete entire cluster. And how exactly a simple deployment into the AKS cluster would look like is like, as we discussed, we initially, while we were discussing on building a Docker image and then pushing into Azure Container Registry, we have the same concept in here as well. We have a CLI client, we have a Docker client with which we're going to pack our particular application code, make a Docker image, and then push on to Container Registry. This can be Docker Hub, or this can be your own Azure Container Registry itself. Once you push that particular image, the image is now available to Container Registry, and the AKS cluster will have an access permission to the Container Registry. Okay, so when you run a command, then when you run an application from that particular image, so Kubernetes will go ahead and it would get that particular image, and then it would run as a pod inside the AKS system. So once the application is up and running, it's now can be served or catered to external traffic. Okay, so how exactly external access can be, or you can give access to your customers, is via the load balancer. or you can have an app gateway in front of your own. If your network is somewhere in your on-premises, and then you can have a load balancer if you are exposing it publicly, and then you will be under the load balancer. You will have the nodes which would be having your particular Docker images running as a container, and the application is has been running for getting catered to the request. So the request, when they actually come via your load balancer to your nodes into the AKS cluster. So that so in case you are using your particular AKS cluster or hosting your AKS cluster inside an on-premise network inside your VNet, then you will have something called as internal load balancer instead of this load balancer. And then internal load balancer can be tagged to something called as app gateway, and the app gateway can take care of routing your traffic from to your company network, and from your company network from app gateway to your load balancer, and from your load balancer to the nodes where your application are hosted. So whenever someone would hit something like www.xyz.yourcompanydomain.com, then the call will directly come resolute to app gateway via the DNS, and then from the app gateway it would come to load balancer, internal load balancer, and from internal load balancer it would come to your node. So that is a complete flow which a specific or a simple deployment in an AKS cluster would look like.
Yeah, so Girish, can we just
Yes.
go back to the slide? I
Yeah.
just want to, double hit few
Sure.
important points over here.
Yeah.
Okay, so guys, you can see there are two boxes, right? So one is on the left, one is on the right. So let's just look at the left box right now. So left box represent the things that you need to have on your computer, so that you can talk to the Kubernetes, wherever it is, whether it is some on-prem server, whether it is Azure, whether it is Google Cloud, wherever it is. So you need Azure CLI, you need Docker Engine, you need a Kubernetes CLI that we call kubectl, kubectl, whatever you may prefer, but that is what you need. And then local Docker container, if you are running local Docker locally, if you're running Docker containers locally to develop, and then pushing it to the wherever you want to, and then we will tell where you want to push. That's what you need. So this is the left box, that is what it is representing. Once you have done your local development, once you have done your local Docker container, everything, you need to push somewhere. And that's what Girish is showing you. That container registry is something that where you publish. Normally, you publish to Docker Hub. Girish will soon explain it in the next slide, what is Docker Hub and all those things. But yeah, you need a place where you can push your work. That is what the container registry is. Now, from there, it has to be taken to somewhere where it is actually hosted. And that's what the right box is. Right box is your Kubernetes cluster, and that is hosted by Microsoft in case of AKS. In case of other cloud vendors like the Google Cloud Platform or AWS or whoever it is, or maybe your on-prem cluster can also be made as a Kubernetes cluster. So that's your right boxes. Now, in the right box, if you see, there is a master component. In the previous slide, Girish has rightly explained you how requests come to the master and how the things happens with the scheduler and all those things. But yeah, this master is something that is managed. In case of AKS, this master is given freely to you by Azure, the Microsoft. So what it is, Microsoft manages dedicated infrastructure to run your master server, so that your request, whatever request you make with the Kubernetes, it will never fail. At least your request. The moment you hit to the master, then master figure it out what needs to be done, and that happens on the basis of how things has to be working out, and all these things will be in coming slides he will be explaining pod and all those things. But yeah, this is the master is the main component that is given by the AKS, freely available. You don't have to pay for it. The moment you create AKS cluster, you get a master node, and that is manageable, that is managed by the Azure, that is Microsoft, and you do not have the full control on the master, as you know, because it is being managed by Microsoft. So you don't really have the privilege of doing everything, but at the same time, Microsoft is responsible for managing it. Now, apart from it, you have node and you have additional node, if at all you need. Node is your actual workload where your apps runs. When you create a container, local computer, you are running it on your laptop. But if you are pushing it to the AKS, GKE, or any other Kubernetes cluster, it needs a node to run it, a virtual machine. In case of AKS, it is virtual machine that is called as node. And then again, there is a complete architecture that where Girish may go in next slide. But that's how it works. Your node actually hosts all these things, and for node you are paying, right? You are not paying for master, and that's how the whole structure is coming up. This is how this thing comes up. And then once you have loaded your application on the node, you can expose it to the load balancer, to the API gateway, to the any other front facing device, the way you do it for any other service, right? I mean, if you host application on your virtual machine, if you host application on your web app, if you host application using any other hosting mechanism, that's how you host it, right? You put up you put a front gateway or API gateway or your load balancer, external load balancer, or application gateway, those things. And that's what it is coming in the middle, I would say, bottom side of the middle side, Azure load balancer. And that's how the complete picture is coming up. Girish, let's go to the next slide. Yeah, you can be thank you.
Sure.
Thank you so much.
Sure. Thanks, Ashish. So Node, in order to take out your confusion, Node is nothing but a virtual machine beneath, and like you have and node pool is collection of virtual machines. Okay, and the customer managed node is the node like which you can spin and you can choose the size, but the master node you do not manage, and you have very little logs to get from the master as well. Okay, and then so the node logs can be found in if you have enabled monitoring, or if you have used log analytics, then you can find the node logs. You can find the logs of your applications which is running as a pod or something, which we will explain from the log analytics as well. And going further, like if you're using something called as if you want to run your AKS cluster, tag it to your particular enterprise VNet or network, then you can do it where you, while creation only, you need to choose network of your on-premise virtual network, and then the nodes will be spun inside your on-premise virtual network instead of spinning up in any public VNets on Azure. And let's go ahead. So what are pods? And the pods are something like smallest or the simplest, smallest building blocks I can say in Kubernetes. And you can see the pods. Pods would be assigned with IP addresses, and the collection, it's sort of collection of all nearby co-located containers and volumes. Volumes are nothing but storage, you can say, and then you can say them as a pod, and then they actually run in the same execution environment, and they are sort of single atomic unit. Okay, so when you run a pod, so you say like you run a pod, you do not say I'm running a container, right? So because pod has a some sort of a little bit IP address, physical addressing you get with pod. Again, it's virtualized IP, virtual networking only, where you can see this particular IP 10 dot some IPs which you get. So that would be given onto the pod, and you can distinguish a pod with the IP, but not for the container. And the apps running in the pod share same port, and the port and the IPs, everything. And if you have the two different applications which are running on the same pod, then obviously the IPs are same and the port are also same. So you need to mention like you need to take care of doing that. If you want to isolate or expose multiple applications, then you will be spinning up different unique pods for each of these applications. And then pods are immutable in nature. Like if you change the definition of a pod, then the previous definition or the previous pod with which you created using a definition would be killed, and that old pod will be killed, and the new pod would be created with the new definition which you have applied. And like you can see, like the containerized app would be part of pods, and volumes are also part of the pod. and these all uncirculated under the node because they all be running on inside underneath the node. And there are two types of configurations when we take care of when we talk about Kubernetes. So one is declarative and imperative. But if you see more about this configurations, what type Kubernetes picks up is declarative one, because imperative are the configurations where you explicitly order a system. Okay, like you run a series of commands and then you say a system to execute those particular commands. Okay, and but Kubernetes is declarative. The users are declarative configurations because the configurations which you mention, which you declare via YAML, they actually the services will try to get bound or to come to that particular state. Like you define a state via the configurations, and then your services will try to become into that state. So that's why that's a one particular thing which makes a Kubernetes more manageable, more dynamic, and more reliable. And then if we go into the more of the life cycle of a pod, and we will be explaining like where exactly the life cycle starts. If we take an example.
Before we get into the
Okay.
life cycle, I just
Okay.
put in the what why pod. Okay, so
Okay.
we have I will again go back. Okay, and I will
Sure.
just try to again visualize the story here. What Girish has explained already. We have the Docker. Fine. We started facing issues with many Dockers. Then we had a orchestrator. Orchestrator is Kubernetes in our case. Kubernetes is having nodes. Node is nothing but which is hosting our application. For managing all these nodes, we have a master node. Master node is coming from the Azure in case of AKS, freely available to you the moment you create AKS. Now, what is pod? Right? It is a new thing is coming into picture. So what pod is? It is kind of a logical unit, which can host your containers in the on the node, which and then Kubernetes directly contact the pod whenever it wants to contact the container, right? So this is how this relationship is happening now. And now Girish is explaining that what is the life cycle of that pod, how that pods can be created, how they are destroyed, how they are rescheduled, and all those things. Yeah, Girish, can you please sorry,
Yeah,
yeah, please.
sure, no problem. So that's what we will take an example of a pod, and we'll see how exactly the life cycle of a pod, where it starts and where it ends. And so it starts with a user typing up kubectl, and he runs an help chart or something which actually spins up a pod. Okay, so he ran a kubectl command. So the first command, as I said, like whenever you run a kubectl command, it would they are nothing but a REST API call which are coming. So this would be hitting directly to the API server, and the API server now would respond. And in kubectl command, we have mentioned something like please create 2 replicas of my pod. Okay, so you give the image like what exactly would be the image of the application you want to run, and you mention like I want a replica of I want at least 2 replicas of this pod running at any moment of time. Okay, and you pass this replica or the configuration as part of deployment YAML, which we will be explaining further. And then like the API server now talks to HCD, the HCD data store, and then it would store that pod specs which has been provided by the user. Okay, and the pod specifications are stored with every information, like whether how many replicas it wanted, it had mentioned, the user has mentioned, and what is the type of type of the pod which we are trying to, the user has set to spin it up. Every details would be stored on HCD database. And then the scheduler would it keeps on running, and it would read from the specs, and then which is in the HCD database, and then it what it does is like it assigns a node for these particular pods. Okay, and so now the pods would be tried to be will be created on these particular nodes, and then they would be assigned onto specific nodes. Once it is done, the kubelet kicks in, and the kubelet, as I said, like kubelet state, save the states of pods nodes, because there was a state change where on the node and the pod has been created newly. So kubelet now kicks in, and then it verifies whether any existing pods are there with the same name in the HCD, or they have registered earlier or not. If not, it would just go ahead and then allow this particular pods. And in cases where you want to try to scale up or delete or recreate, a new command comes in, then also this particular kubelet would take an action to verify this and then spin the pods if they're not persisting already. And in case like a user says that kubectl run a pod for me, I specified 2 pods, and in the next series of command, user realized like no, I wanted to have 3 replicas, 3 instances for more availability. Then once the user runs with that particular new replica changes, these all series of actions happens, and the kubelet actually verifies now whether the pod with the naming conventions or the same deployment file exist or not. It would check and it would see that yes, the 2 pods are running fine. By a user want again, then it would check onto the replica how many instances, number of pods a user wanted to run. Then it would try to spin one more from the deployment file, using the deployment file as an image snapshot, and then it spins up one more pod in either of the nodes. And going next, what happens is like the controller manager will kicks in and it would verify the correct number of pods running in the cluster at any point of time. Okay, and so that's what is the complete pod lifecycle. And then
and
so
just to double
yeah.
click one thing here, that if you the complete life cycle is little bit, you guys should be kind of going again and again, have a look so that you can get the architecture of the Kubernetes in general, and then you will be able to figure out whatever Girish is able to, Girish is trying to kind of establish that this is how it happens. But the one thing that is very, very a highlight over here is that Kubernetes do not talk to container directly. It talks to its pod, and pod, the Kubernetes understand the pod completely, its structure, the way it works and all. And that's how it actually kind of create its framework of managing the containers. So and that way it is also segregated from the development of your container image as well. So yeah, as you might have heard of that, when you are creating some application, in past what you used to have is you used to depend on a lot of the platform that is going to host it. Like for example, if you are developing an application based on .NET, and if it's supposed to be hosted on IIS, you have to make sure the application is structured in a way that IIS can understand in some way, similar to other platform as well. Now in case of container, this is not the valid thing, right? So you create a container, you create an image, and the moment you create a container image, it can be run anywhere, whether it is Docker Swarm, Kubernetes. Anyone who can understand container image, he can run it. And that's how Kubernetes runs it. Kubernetes creates a different level of what I would say, different level of understanding over pod. It controls pod, it doesn't control container, and that way it is able to kind of work with any way you develop your container, a very similar way, and that container can run in any other infrastructure similarly. And that's why it is kind of making sense that you have a concept of hybrid cloud, or or private cloud or public cloud, where your Kubernetes is something which can run in the same way, the way it works in Azure, the way it works in Google, the way it works in on-premises. So that's how the things are related over here. Yeah, Girish, let's go.
Yeah. So yeah, thanks Ashish. So what we can observe from these pointers or this learning is like Kubernetes you can spin anywhere. If you have a Kubernetes knowledge, you can actually work with GCP or the AKS, Amazon, AKS or EKS, any particular cloud. It's all depends upon your Kubernetes expertise. So those who are attending, especially for learning Kubernetes, for them, yes, I would say to explore more in, and then expand your horizons and more opportunities on other cloud vendors as well. Yep. Next. Yeah, so let's talk about replica sets. And replica sets, in simple, as I said, like if you want a number of instances, like you have a deployment file and you have a replica set where you mention like you want 3 instances of your particular application. So it spins up 3 replicas. It ensures like uh, uh, it ensures like these configurations have been pushed to the manager so that he take care of maintaining at least 3 pods at any point of time. So if I describe more about the replica sets, so they are the KX objects that usually manage pods, and the best thing is like they are very redundant, and either they allow or they fail. They show up the result very quick, and then it would also allows you to scale. It would allow you to scale your instances or number of pods to more, so that you can process more number of requests at any point of time. And then it monitors the cluster, and also ensures like these number of pods or the defined number of pods are running at any point of time. It does scale up if the pods are lesser than the expected, and it also scale down, and sometimes it destroys the pods if there are in excess in number, and if and like if the replica set has certain configuration, and if the user had manually spun up another pod. And yes, we use deployment objects to create a replica set as well. So it would go as part of a deployment YAML. So YAML is another extension which I talk about, and YAML is a go to file extension, which I can say if you are working in DevOps world, or if even if it is a setting up a CI/CD pipeline or anything, or you want to interact anywhere in the Kubernetes worlds, and with any objects you interact with YAMLs. So that's what is the deployment YAML will have the property of the replica set it carries out. So when you when you run your deployment file, it actually sets your replica set and the configurations which you mentioned underneath it. And let's talk about deployments. And since we know about pods, we know about replica sets, we'll be having a little bit idea on the deployment now. So there's also KX objects, but it maintains or controls the running state of a pod and replica set both. So it instructs the deployment controller, which we have, which we saw in the cluster architecture, to create, scale, upgrade, and update any of the instances of the services at any point of time. And then it also has a fine-grained access to the pod state. So if you want to set up some state or some settings onto the pod, it's actually you should mention as part of deployment YAML itself, and then it would take care of once you run the deployment, it would take care of persist in the same state whatever you mention onto the pod. And the K8's deployment controller also reads the deployment and schedules the instances, whatever you mention on the nodes on the cluster, irrespective of whether you have a single node which is running or multiple nodes which are running. It take care of spinning up using the default master node capabilities with it. And then like deployment operations are very simple with this, so you can actually create your own deployment. You just do kubectl create deployment, type kubectl create deployment, and then you give the deployment YAML, and then it is done. And in order to delete, it is like you can delete a set of pods, like which have like if you can take an example, like we have this deployment, and using this deployment we have spun these 3 pods, right? So if you want to delete these pods, what you will do, like you will go and delete a single pod by the name, right? So these are the naming convention which is maintained inside the Kubernetes. And Nginx is sort of one particular example I can say is a pod. Nginx is a reverse proxy software which is used to the underneath, which is just stands before your particular nodes, aka cluster nodes, so that it takes care of all the pod IP addresses, the service names, everything within. So Nginx is that particular offering, and in this example we have Nginx deployment which we did Okay, and it has these number of pods which are running. So when you just go ahead and say that kubectl get pods, you will get the list of the pods with these names. And if you want to kill it, you can go individually kubectl delete the pod name and give the namespace name. If you have something, it would delete. But think of a case, right, where you have hundreds of pods which are running. So in that case, you just go ahead and delete a deployment, the engine's deployment, and it will delete all of this pods and the configurations related to it as well. In order to update, you just need to update the deployment definition itself, and it would create a new pod with a new definition. As I said, like it's immutable. OK, let's go for the question. Kubernetes configurations are what type? I mean, like uses what type of configurations by default? So I would repeat my question. What type of configuration Kubernetes use? Is it imperative or declarative? You can go here and answer your question, and we will track the answer. I would repeat again. Kubernetes configurations are, is it imperative or is it a declarative? I'll give you a few more seconds to answer. Who didn't answer yet?
We have extended a little bit of time because people were facing issues. So we will wait a little bit, 20 more seconds. Sorry, guys, our URL is kind of not able to sustain the kind of demand, I mean, the request. So yeah, we will take care in the next session. Sorry for it.
It will take time, or shall we move ahead and then see back the results after some time?
Not much, just 30 seconds more. Okay. That's it.
Yeah. OK, no problem. Thank you. So those who didn't answer yet, please answer. It would also give you some sort of confidence, like you understood something from this session.
OK, so we have the result now.
Nice. People are listening to me then. Yes, the answer is declarative.
Indeed.
OK, let's go ahead. OK, so this is the last module of our theory, and we'll talk about serverless computing. OK, there's a lot of buzzwords. We covered a lot of buzzwords. We covered containerization. Now we're going to cover serverless. OK, and so when I talk about serverless, there is no server. OK, so we are going to describe the serverless computing in few of the categories which is available through these particular services. The one is Azure Functions, and the second is Azure Logic Apps, and another one is Azure Event Grid. OK, and these are the few categories which we will try to explain, and explain the concept of serverless computing, how it has been implemented, and how you can take benefit, how your applications, your teams can take benefit of these particular three categories to automate a lot of manual solutions which you guys are doing till today, right? Let's go ahead. So Azure's function is also a serverless computing service, and basically when I say serverless, it's like, you do not know or don't know where exactly your particular code is running. OK, I mean like the workload, you just give the workload to the Azure, and Azure would take care of running it, and you do not need to bother about what sort of the size of VM on which you are running, where exactly it is running. OK, it's all, and then you are only chargeable with amount of time you run, or the number of time you run your code. OK, and it's like 1 lakh sort of transactions transaction per second it can take. It has a lot of durability as well, which we will go through. And if you take an example of Azure function, you have a code. OK, the code, for an example, it sends an email. Okay, and it sends a generic email like you have subscribed to our channel. Okay, and to your subscriber it would send an email. So that's a thing that's a particular simple code you have, and you have written in .NET or Python or anything. It doesn't matter. Okay, you just take your particular code and you spin up Azure function. You copy your code onto the Azure function, and you bind it with something called as events. You can trigger this event when you want to trigger that particular event, like when you want to execute your particular code. Okay, so it's sort of event driven architecture it's embossed into. So you have a code, and you want to set an event, like whenever a new user comes to your particular account, your YouTube account or anywhere, or your website, when they subscribe they should be sent with a welcome email. Okay, so you have a welcome email which is very generic, and you have an event or trigger. You will say that whenever someone comes and hit that particular my YouTube, this one, then that would hit a web that particular application like YouTube app or any particular website would hit a simple trigger call via an HTTP call. So HTTP call can be like the simple way is like if you searching for google.com or something like, so you're trying to resolve, you're making a call. If you open a page, you're making a call to that particular domain, right? So it's very simple like that. Once you have an Azure function, you have your code, you can actually generate an webhook URL, and you can give that URL to your YouTube or any particular app. And whenever an event happens, or when someone subscribes, it will get that particular details and it would hit that particular webhook URL. And then once that particular thing happens, it will trigger your code to run, and then your code will run and it would send an email as a welcome email to him. So that's one thing, sort of what I can say is like implementation you can do with Azure function. And you can also persist this particular that you have sent an email to a customer on a database, something like on a storage or NoSQL databases, by using bindings. Okay, so these are the three components which you use to make your Azure functions, and you can see like you are not mentioning on which server you need to run or what is the runtime of your applications. Nothing you're mentioning. Once it's a one time, you mention your code and then you mention what type of code it is. That's it, and everything would be taken care by Azure. And so that's what is serverless, because you can't see an actual server which is running underneath it. So you can write code in any language, and you can integrate with Azure function, and it enables user to run event triggered code without actually managing physical server. Physical server, as I said, because these are three particular inputs which you're going to take, nothing more than that. And the scenarios where you can opt for the Azure function is like when you want to make a particular decoupled architecture, like you don't want to have a dependency of the services all hosted on a single box or something like that. Rather, you want to have something like you want to have a code separated from each other. Like think about a simple example of an e-commerce where you have an order queue, and you have an delivery queue and other particular queues, right? So each queues are independent to each other, and there can be an independent job which can work on that particular queue to read it, right? So you can have in such scenarios, which is that particular scenario, it's a decoupled architecture where you have a different queue system which has decoupled all of your services into smaller chunks. So you can use Azure functions in there to process your particular messages in there, and then and give you the output or do the next activities. And then you have something called as the Azure function has very durable, and it has very high throughput, which can actually process 1 lakh events per second. And it is not me who's saying it, it's published in Microsoft Docs, which you can go and verify as well. And the reusability is good, because once you mention the code, if it's a welcome email, you can actually reuse that particular code in any of this, whether it's on YouTube or whether it's on any other particular subscription you're talking about. You just need to change your dynamic content in your email and everything is done. So the code is very reusable, and you can use Azure functions in multiple places. It has the architecture which can actually resist in case multiple requests are coming together. And shared resource usage, yes, you can use, you can create an Azure function and you can use in various different services. It do not have any tightly integration with one particular services. Like service one is talking to Azure function, it doesn't mean that service two can't talk to Azure function one. So that sort of capability Azure function has. And Azure Logic Apps, if we go ahead, and then Azure Logic Apps says more about you can use, you can schedule, or you can automate, or you can orchestrate any of your tasks which are very regular or manual. This is very important to people who wanted to who are working in teams where they are doing the automated task each and every day. And this is a topic for you, which because you do not need to write a single piece of code. You just need to have a logic. You just need to know how services work, Azure services, or any of the heterogeneous services, how they work. That's the only knowledge you want, and you can write your own steps. Write your own steps to describe the logic. Like if you want to read something from one particular service and then post on somewhere, you can mention or use this particular logic apps easily, and you can create your own logic apps within few minutes without actually having a prior knowledge on coding even. You can build scenarios, like you can build scalable solutions with this, and it has a very good integration with heterogeneous applications. With any of the apps you run on Azure, they have good integration with that. A lot of support are coming up slowly. And even if you don't have any connectors, basically use connectors to connect services of different heterogeneous. So for example, if I take here in this, you have application insights. So application insights is a performance, like what I can say is like it's an monitoring tool or APM tool, I can say. And what it does is like it reads the statistics of your particular applications and stores that particular logs. Okay, and it also has something called as alerts or something like that, which actually you can set on top of your application, so that if number of requests are crossing more than the expected, you can alert your system, alert your particular action group, your particular team. So similarly, in application insights, you have this application insights alerts. You can actually integrate the application insights alerts with logic apps using the logic apps, and it has a native connector which you can directly natively coupled, so which you can directly use. And in case of any alerts, it would actually you can using a team connector, you can connect to your teams, your particular team, your particular group, and then it can post your message about that particular alert directly into the teams without actually a person going and logging and checking in every 24/7. So you can write your own custom message about that particular alert and then post onto the teams, and loop in necessary teams to take action in such cases. So this is very important. I would suggest you to give a try on this. And you can integrate with a lot of data integration systems. You can integrate a lot of old systems as well using BizTalk, and you can actually create a lot of Power App connectors. So Power App connectors can be used or can be used in Logic Apps because there are many systems which are traditional, and we do not have connectors already built into the Logic App. So you can use a Power App connector to write an API onto it, and then bring create your Power App connector, and then use that Power App connector into the Logic Apps, and then you can integrate any of your traditional or old systems as well. And then yes, it's good for enterprise application integration because it has certain easy integration with services. And yes, it's used for B2B communication as well. And then going forward, let's go to the next topic, the last topic, in fact, Azure Event Grid. And Azure Event Grid is sort of built in on top of all of this particular services, Azure services which you have. So it has a very good integration with all of the Azure services, and it basically used in routing or managing the events from publisher to subscriber. So it can take or manage from any of the event publishers like these. Um, in your system under your Azure subscription, and then it can route onto, or you can actually use it to set up any automation and other particular activities by dumping that notification to via webhook to a webhook or to an automation account to a logic app or to an Azure function. So Event Grid is on top of all of this particular Azure services, and you can do a good event management or notification management with using this particular Azure services, Azure Event Grid service. But again, you do not find any particular infrastructure which is running beneath this particular Event Grid. So that's why Azure Event Grid is also a part of serverless computing. And yes, for a lot of event driven and serverless apps, we use this, and I would suggest to give a try on the Event Grid as well. And it can route events to any source to any destination. That's what I can explain you right now. Yes, with this, let's go to our question 5. So the question is, which Azure serverless computing service do not need you to write code rather than just mentioning a logic? So I repeat my question, which Azure serverless computing service do not need you to write a single piece of code rather than just mentioning a logic which you have? And the options are Azure Logic Apps, Azure Event Grid, and Azure Functions. So let me your answers on this particular URL or by scanning this particular code. Everyone is trying to answer.
Yep. Yeah, it will take another 1 minute to give us the
Yeah,
answer.
no problem. Yes,
So
no
yeah,
problem.
people are responding. So
No problem.
about 40. Yeah, it's increasing. People are able to reach this URL. I have posted the direct URL in the chat. So if you guys are not able to reach there using the Azure Easy link, you can just click on the link in the chat and you will be able to directly hit the quiz. Yeah, so we are about to get the result, and yeah, time is up. Results should be there. Yeah, Girish, if you can refresh your screen.
Okay. Cool. People are still listening. Okay, yes, the answer is Azure Logic Apps. Yep. This will take a break. I'll start a timer.
Yeah, please go ahead. Yeah, so guys, we are having a break of 10 minutes, and we'll be back after 10 minutes. We will have a hands-on demo for all these, few of the tasks that we'll be performing out of this agenda. That was part of the today's topic, and then we will cover all the kind of question and answer as well during this break. So yeah, start posting your questions. We will try to answer it as much we can, and if we are not able to answer your questions, I highly recommend you to join our Telegram group. There we discuss a lot about all the types of issues with Azure, and there are a lot of people, more than 7.5K, I guess. Yeah, we are almost about to reach 8K in some days. So yeah, there are 8,000 people there, and a lot of expert, beginner, all kind of questions. Anything you have on Azure, you can put it there, and then people will be able to answer you. Whether it is learning, whether it is issues that you are facing in your day-to-day job, or it is about any service or something. So yeah, we will try to answer as much we can, but at the same time, I will highly recommend you to have a similar kind of discussion over chat there. I mean, we will, we do have a very interactive chat over there. Many of the core team members also answer there, and at the same time, there are so many expert people across the globe who can answer your questions related to any different services. I will just post the link for the group in some time. I'm just waiting for questions to be coming in and spreading. Thank you.
Okay, guys, let's start. So we will going through a few of these demos. So we'll have lab one where we will choose and will contain a web app, and then we'll deploy onto an app service, and then we will play out with the app service scale up and scale out. We will use some real-time load putting application which I have in hand, and then we can run it, and then we can scale and scale out, and then see that particular workloads how exactly it is making impact. And then we can use a Docker image, and then an Azure container instance. Like we will pick up a Docker image, and then we will run your applications or website from Azure Container Instance itself. And then we will come on to more on Azure Kubernetes service, and then we'll spin up a pod, and then we will scale our workloads on AKS as well. Let me switch back to my browser. So this is my subscription. Hope you can see. So what I'm gonna do is like our lab will be doing using Cloud Shell, and then we have a Git repository. Yes, so this is particular repository where I have checked in all of my commands, and then it will be available not in my GitHub repo, but I will be publishing on Azure Talk as well. And in YouTube, we will give the link as well in the description, so that you can use this particular command and execute them. Okay, so the first lab talks about deploying a Docker image by using an Azure container instance. So what we will do is like for this, we want Cloud Shell to be set up, right? So Cloud Shell is again what I can say is like it's a client which is running on Azure itself, and basically it's running on the file share and storage account you define. And if you're setting up this for the first time, when you click the Cloud Shell icon here, then it would ask you for setting up the Cloud Shell using, and it would ask you like whether you want to choose an Azure file share or a storage account. And then once you give that particular account, it would boot up, and then it would authenticate, because it's again a client. It need to get authenticated with your logged in credentials with AD or RBAC role, whatever you have signed in. So it does those authentication, and it just brings you to the home screen. So what we will do is like I've created this particular resource groups and this particular subscription. It's always suggested you have proper tags on the resource group so that you can put some automation and other particular a solution on top of it. So let's go ahead and start with our first lab. And what I will do is like I'll create an ACR. So Azure Container Registry you can create manually also, and you can also create via CLI. A manual approach would you can go through it in any of your particular solutions. If you go through like Google search or anything, you will get onto the manual how to do it. Okay, and I'll just go to my subscription, my resource group. Okay, this I would switch back the directory to mine. Okay, so the manual way how do you create is you just go to in your resource group also you can go, and then you can add resource. So this is from so all of the services, whatever you want to spin, you're gonna spin from marketplace. If you have certain solution in here, you can also search from here. And I would uh, want Azure Container Registry. So you can use this particular way to also to create, or you can just use a CLI way to create it. For that, you can run this particular command, and so I'll explain about this particular command, what it carries. So it says AZ is basically AZ command to interact with the Azure, and then ACR, Azure Container Registry, it would create, and you need to pass on the name of the ACR, and then you need to pass on the resource group in which, because resource group is a logical separation, right? You need to mention it so that it would create resource in that particular resource group, and mention the standard SKU and admin enabled. I will say what it is. Edit, and then my ACR is created. Yes, so you can see my ACR Azure Container Registry ACR tag is created. You have in Azure, once Azure Container Registry is created, you have repositories, and as I said, it's very similar to Docker Hub, but it's more of private repository and have a lot of RBAC rules and identity and other authentication which have been integrated, and a lot of securities have been integrated underneath it. So that's why most people at enterprise level solutions, they always prefer to use Azure Container Registry, and these are the locations, repositories where you will be the image you build, a Docker image you build, you actually push into it. So you push into a repository, and then it would be listed out in here. And then so if you want to set up CI/CD or automated deployments, then you can actually use something called as webhooks for this, which I'll explain. And if you want to replicate your particular image, which is available in specific location, so once we create the create an image onto the onto Azure Container Registry, it would push onto repository, and it would be contained to a specific region, and where you have spun. Okay, if you spin a premium Azure Container Registry with premium plan, then you can actually spin it to any other places with over just a click. If you have spin somewhere in US or India, and then you just select it, and then wherever you need to replicate, you can select the location, and then it would replicate without you writing a single piece of code or effort. So that's about Azure Container Registry. And what we're gonna do is, like, once we created, now we will go ahead and build a Docker image and upload to our Azure Container Registry now. So for this, what we can do is, like, we will be taking a particular image which is available on GitHub, and you can directly. So this is one particular app which we will be using to deploy from the Git repository. So for that, we need to clone the code first, and we can do from our local itself instead of local in the sense my cloud shell itself. So I would do. So I've already path is existing because I've cloned yesterday. So if you are new, then it would say to create. I would just switch over my folder to this path. Yes, I switched the path, and then now I'll go ahead and build the code. On the fly, I'm not putting I'm not using any of the dependencies or something to build it. Everything is right on the Cloud Shell. I'm triggering, and then I took the code from the source code from GitHub, and then I'm building the code. It's sort of like picking up your own code, but rather you just kept on GitHub. So it does all activities. It's pulling the code. It does the scans everything before pulling the image directly into your private container registries. It just takes a few seconds to complete. So it's saying to like this is running a container on this particular. Okay, the container is running. So go back to here, and you can see your the stored image. You can just go. You can go to the repository. Let me refresh. Yes, here is my image. We build the image and then we push the image onto the ACR container registry with the latest tag. Okay, so you can see like if you want to pull this particular image in your local client, you can just use docker pull and ACR tag, which is my container registry name, azure.cr.io, and then it's the repository name. And this is the latest, it's the image name, and this is the latest tag for that particular image. You can use this and then you can clone it, like you can pull this particular image in your local and then run a container by just docker build you do and then just docker run, and it would be running fine. And if we go back, so we have it's running. So what we can do is, so and then we will go ahead. Set tag, just create a duplicate tab. Okay, so we have the container registry, we have the image, we have pushed that particular image, and it's ready to run and deploy. And now what we will do is like that's finishes our first lab, and the second is like we will be containerizing a web app and deploy to app service. Okay, so now you will see more of like we will use this particular image and then using app services, app service, we will pull this particular image into the app service and we will see that application running. So for that you can do the manual way, like we will go ahead and create an app service with app service plan into the same resource group we're gonna do. This is my resource group. So I will create a web app, which is an offering from app service as we read.
So what we are doing over here is, we have created the image. Once we created the image, we have pushed it to a remote location, that is ACR. And now we have different options to host it. We can host it on your local computer. Yeah, fine. We can host it on some other places as well. And Kubernetes is one of them, but we will go there. We will go there in the end. But what Girish is trying to show, without Kubernetes, you can still host your app, and that is the starting point. Maybe is something that Girish is explaining. Your web app, normal web app, can also host your Docker image. Apart from basic way of hosting different applications.
We are just trying to we just try to host user image which we just dumped onto into Azure Containerization and we will use directly. Yeah, so we can name that particular app specifically, and let me name as something like and I would use a Docker container because I have already the image. Okay, code. Just a minute. So you can see the steps in here. For I'll just go with the Docker container. I'll choose Windows, any location I'll choose. I'll create an app service plan. I'll go with the default one, premium. I'll just reduce this size since we have the option of we discussed about in basic, free, basic and shared. So you will get them here. And for the production workload, you have these particular offerings, and isolated it is different app service environment itself. So let it open. Let's pick up this PC2 production workload as of now. And next Docker, we will be picking up the image from here. So we have our container registry. So I've selected my container registry, and then it would populate since I have single container registry, it's populated, and the image also it populated, and it is picking up the latest. And I'll click on the next. Monitoring as of now, I'll disable it. I'll create it. So it would validate all of the parameters which we have mentioned. And the app service plan also we have chosen one premium. So with premium you can scale up as well, as we went through the slides. We can scale up, scale out, there's no limit. And this is just an example. So okay, let it go through. It would just take few more seconds. Yeah, our app service plan is created. So the deployment, whatever happens, so it says failed underlying API. That might be useful. Okay, let me see what is the issue here. Okay, it says that it doesn't support Windows container. So I'll try to redeploy. And then I'll just change that container type. So scope. Location also we should change. Hosting environment. We don't want Windows, we want Linux. I don't see an option here, so let me recreate it, because if you redeploy, you should get those options to create it directly. But since we didn't get option, I will go ahead and do the same activity again. I'll come to web app. I'll fill the web app tag. Linux. was I just run something? Yeah, I'll just take up any of the code option, and then let me select ASP.NET. Central US is okay for me, and plan is okay. So I need to select the image. Okay. Yes, this we need to select. North Europe plan is same. Docker, and then we'll select a container registry, and then our image. Okay. No startup command. Next. 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 Create. So probably it's I'm not sure. It's throwing error. Okay, it says premium V2 is not available for this. Let me try to change the plan. Okay. Yeah, now the dev tests are loading. I'll just choose any of this. I'll choose B1 and then I'll go ahead. I'll review and create, since we gave all other parameters earlier. Oh my God. Okay, let me switch to another directly. Sorry for these errors. So I have my resource group in here. I've just chosen a different subscription itself. And let me go and quickly run the commands so that you do not need to wait much. I'll quickly run the commands for building our code. How did we do? I'll create a similar Azure Containerization in here. I don't want to skip the so just a different subscription, so it might work because that resource group was showing up certain limitation. Once I have container registry, I will pull the code from Git repo and then build an image and then push an image onto the container registry. Let the container registry get created. duplicate also. Let me cancel it. Rerun again. Okay, I'll just change the name. Probably it would have created, or the operation was in pipeline. Okay, let me rename one. Since that has been created in another subscription, probably that's why it's not able to give. Okay, so it will load up here, and then meanwhile I'll get the source code from the GitHub. Okay, I got the code, and now I will switch over to the folder because I need to build the code from there and then build an image out of it. I switched, and now go ahead, build the code, and then push the image onto the Azure tag. I need to rename the Azure tag 1 because the registry is different. Yes, it will upload onto the registry. Yes, it is your tag 1. So inside the repository, we should see the image soon. Refresh. It's downloading. It's building the code, and it will build the image and then push in there. So meanwhile, we can also create the app service. So where we will we'll create an app service, an empty app service with the Docker image, so that it will take that particular image and run an application out of that particular image. It says it's the build image run. Okay. Came to the resource group. I need to create an app service. I'll go ahead and create a web app. Okay, and give web app tag 1, and then I'll choose Docker container. As it is, I'll leave it, and premium size I'll just change to B1. Yeah, here's a basic one. So since we do not want to do any scaling for this particular application, it's okay. And then I'll go select my image which I pushed. So my image came. Next, we don't want no tags, review and create. I'll create. Let's discuss about the other commands meanwhile, and then so once we get that particular code, we have the app service running, we can actually run another one where we will just we can automate, we can set deployment automation into our app services on image update, like it's like automatically deploying or creating a new image whenever a new code is committed onto the source, like if you're using a GitHub or using Azure DevOps repository, like if you're someone is checking or committing the code, then it would create a corresponding image as well. For that, we can just go to the portal onto and to the container settings on our Azure Container Registry, and then click our container settings as on, and that would take care of doing it. Let me see back. Yes, our resources has been spun, and let's go to the resource group to see. Okay, so this is our web app, and since we spin this particular web app from that particular image, we should see application soon. So I can access my app services web app with this particular URL. Sorry, there's a lot of lag. So meanwhile, we'll go to our ACR image which we created, and we want to check the container settings. Okay, web app. I'll refresh. So in here, if you come to container settings, you can set automated deployment, because if you see an example here, so you have an image in here in this particular Azure Container Registry, and whenever any change happens onto the code, whenever a new image has been created or latest has been pushed onto this container registry, or this particular old image, if it has been modified or a new image has been created, it should actually deploy automatically. It should, our web app should know about that particular change automatically and pull this particular latest code or latest image, right? So for that only, you can go into the web app and click on the continuous deployment. Okay, once you do that, so it would have this web app webhook URL configured to it. So so whenever a change happens in here via the webhook, the web app will be known. So you can see the webhook like this, and this webhook URL would be invoked whenever a new image comes in here, and then the web app will be alert, and then it will go and pull that particular latest image from the repository, from this container registry. So you can see this application is running, and we can if we want to test how exactly this continuous integration work, what we will do is, like, we will go ahead and then we will do a little change to our existing file. So I will go to this particular specific folder, and then I will just move the old file. So basically what we're going to do is, like, we're going to change this carousel, which is visible here, into green. So that and then without actually running by our own, the CI/CD, the inbuilt capability should kick in. So yes, I moved the new file there, and then I will go to the folder to rebuild the image, because we need to rebuild the image and then we need to push, right? And then once the image is built, we will trigger it. Changed it, and then now we will build the image. Okay, I'll make it tag 1. Okay, now you can observe, so you should see the latest one in here, and it should have, so this is the webhook which we have kept it on. So you can see if there is another image which will be built, it should trigger one particular webhook ping request from here to web app. Okay, then the web app will be coming to know that yes, there is a latest image which is available, and then it would pull, and then it will deploy automatically to here. So we will go here, we'll check. Once the image is built, we should see the ping result coming up. And even you can check whether this particular container registry and this particular web app are being integrated or connected or not by just sending a ping result. Okay, if you send a ping, then it would invoke a webhook and it would get the health status from it, and then it will say that your status is okay. So we should see the ping result. This is, and once we have this image built and then pushed, it's copying the files. Once this is done, we should be able to see the webhook get triggered, and then the page get I will just make a duplicate of it so that the new page we can see with the new carousel we should be able to see once the changes happen. We are waiting for the webhook to get triggered. Yeah, it says successful. Yes, we saw this. It took the latest one, web image, and the latest time, and it actually triggered a webhook. So now the web app came to know, like, there has been a change in the image, and at any moment we'll be able to see this particular change reflecting in here. Keep on refreshing. Yes, so you can see the new carousel, it has come up. So we didn't do anything, we didn't run or we didn't deploy it again. We just built the image and everything was taken care. So that's one thing. And so with respect to scale up and scale out, we will test one more lab in where we will clone one more code, and let me start from the home. For simple, for going into it, I'll just restart my, so I'll just it would just go to the home. I'll close this particular demo, let the container registry be there. What we're going to do here in the lab 3 is, like, we will check the scale up and scale out. What we will do is, like, we will deploy a particular website, and then we will go to that particular website, and then we'll see the monitoring, how exactly whether all metrics are working fine or not. Okay, and then we will run a particular load metrics, like a particular client tab which actually randomly creates requests, and then it would create spikes in our scale, and then we should be able to see that. So that would be our last lab in app service, and then we will move to a case. I know I'm running out of time, but let's clone the code, and then I switch to the folder. Okay. And then I just build it. .NET build. So it will build that particular code which we have just checked out into our local, into this Cloud Shell. So let it build, and then once it builds, we will go ahead and to this application hotel reservation system, and then we will publish this website. Sure, we can use the same web app, or we can just directly go ahead and create a fresh one for this. I'll go to this one, create something with the same name so that it would be easy to understand. Let it build. So I'll give the name as in here, hotel system tag. I will name it as, and then we'll use this .NET runtime somewhere 4.7. Windows plan is standard. Okay. Next, I'll just review and create. Let's see what's happening here. Still running. Let our web app come up. Okay. Okay.
So Girish, just
Yeah.
type the name in small character, instance detail.
No, it's actually throwing up with respect to plan, service plan, something.
Okay.
Yeah, but I saw the error. What happened to this? Let me cancel by Control C. Let me run again, build it. Let me run directly if it would have. Pretty weird. Let me simultaneously run here, and then if not, we can give a last try. Okay, the last .NET build which we have run, it's currently in executing mode, so it's not allowing us to take other thing ahead. That's why it's throwing error. I think we need to skip this lab. We can directly jump onto a case because I wanted to show the scale up. You can run this particular steps. Okay, so and then let me explain the steps. So first, what you're going to do here is like you are fetching the code. you are going to the directory and then you're publishing the code after the build. And once you do that, you would be pre-creating a web app, and the web app, into the web app you'll be pushing this particular code, the new app. Okay, and then this hotel reservation exposes an API called as reservations one. Okay, if you hit as many as times, it would populate that much data. So when you scale out, it would show up a good improvement. So what you can do is like you can go and go to this particular client. Okay, and then trigger something, add this configuration via the code. So how you can use the code, I can explain that. So for using the code, you can actually clear it, and then you can type .cod, or you can just type code. So it will open this particular page, and then in there it is trying to open certain files. So let me go there at least, so I can open the app config of this particular file using the code. And then so once you open that particular file, once the build happens, you need to change this particular configurations. Then what it will do is like it will create and run 100 of these clients and then start posting up requests to your API reservation app. So it would do a lot of, carry a lot of loads, and then you can test the loads by scaling out and scaling up, and you will come to know whether scaling out will help you or scale up will help you. Okay, so that was the use case which I wanted to try it out, but it didn't happen. But let's go ahead and just take care, work on the AKS one. And for AKS also, it's quite easy. You can, via the portal, you have Kubernetes service. So this is an AKS offering. And for AKS, you would need something called as an AD app, and AD app, which is required as a service principal. It's a prerequisite, and I can go and AKS tag, I can just name it. I'll just use it. Kubernetes version is a version of version in which the kubelets and other thing would be installed. And you have primary node pool. We can choose the node, as we were saying, like we need a node to run a cluster so that pods can sit up on it. So these are the thing. We have various types of nodes in here, and let's go ahead and select DS2 V2. And as I said, like you can choose nodes, you can have multiple node pools, and multiple node pools can have various different type of so these are mostly, you can have CPU intensive, or you can have something memory intensive nodes like that. And then you can use, and you can mention the node count in here and click next. And this is our primary node pool, and you can also add extra node pools. So this is standard. You can have some memory intensive or CPU intensive, so that whatever applications come for onboarding onto your AKS cluster, you can use them. And there is some concept called as virtual nodes, which is a little deeper, you can explore. And yes, we will be going with VM scale set because we want to spin from 0 to 100 or 100 plus like that. So we'll go with VM scale set, and we'll click on the authentication, which will talk about the service principal. If you have some existing service principal, you can use, or you can use system assigned managed identity as well, where you need to go specifically on services, and then you need to enable a managed identity there, and then it would be done. And I'll not go with RBAC. RBAC, the enabled cluster, gives you capability of using AD, like Azure Active Directory role-based access control inside your particular complete cluster. Like you can before the user signs in into your AKS cluster, you can actually use this RBAC cluster to do the single sign-on, and then provide the multi-factor auth, and then continue. We'll go with networking basics. There are network policies and other things which are at the advanced level, but I'll just go with this. We have log analytics workspace configured, and I will go ahead and create it. The cluster creation takes a little bit of time. Within that, we will go through other commands for the AKS cluster as well. And I will take you through the scaling, how exactly you can scale nodes and how to scale pods and other thing. Now we have just more 10 minutes left. Almost 12 minutes we have. Okay, I'll just create. So this is one way of creation, and meanwhile I can go and show the other way of creating the cluster. Yes, so for creating, so this is the one AKS v1 cluster creation command, AKS non-RBAC cluster command, and it uses an Azure CNA as a network plugin. So you can use two network plugins. So network plugins defines how exactly your pod would be allocated, how exactly your pod would be running, whether they're gonna run with unique IP addresses from your virtual network, or they will get IP addresses which are virtual IPs assigned inside that particular node itself. Okay, so in order to have a virtual IPs inside inside the node itself, you can always choose Kubernetes network plugin. And for using an Azure default network interface, I mean, you want to physically assign whatever IPs you have in your subnet onto your particular pods, then you can opt Azure CNA as it. Okay, so for this, what you can, this is Azure same whatever command we have created, the manual way we have created in here. So we can use something called as the CLI, same from the Cloud Shell. You can use AZ-AKS. So let me explain the command. AZ-AKS create, and -G stands for the resource group, and -N stands for the cluster name, and you can provide the cluster name, and this is the location where you want to spin, and this is a Kubernetes version which we have selected in the manual way. You can also select the latest version, or if you have some constraints of application which can work on a specific Kubernetes version only, then you can choose that particular specific version. And generate SSH keys is by default you need to give, since it's going to run on a Linux machine, and most of the workloads are on Linux, so that's by default. Windows are started supporting now. And for CNI, you need to mention these particular parameters: service CIDR, DNS service IP, Docker bridge address. So this, the CNI uses internally to assign a virtual IP to each of the pods which you're gonna spin inside your network. And network plugin is Azure, which stands for Azure CNI. And you give the VNet subnet ID, I mean, which is a full path of your VNet. So how do you get a full path of your VNet is if you create a VNet, you can just go to that particular resource. Let me just take an example here. So if there is a resource here, if I want to get if this is my VNet, if I want to get a full path of this particular resource, then I'll go to till the subscription, and I'll go to the end, and this is my full path of a resource. Okay, in case of VNet and subnet, you need to extend a little bit more to get the data. And once you have the URL, you need to paste the URL in here for your VNet, and then we don't want RBAC, we will disable RBAC. And then service principal is the service principal which you're gonna provide, which in the manual way we defaultly set to create it, and that you need to pass. And the client secret is a secret which you will create from the service principal. And how to create is like you go to your Azure Active Directory and you can create an AD app in there. Okay, AD app is nothing but the service principal, and you create a secret in it, a client secret, and then provide the client secret here. And you provide the AD tenant ID, which is basically the directory ID, which means that in this one, this directory is there, right? You have the directory ID, the GUID, which you can use. You can provide that GUID in here. And then attach ACR says that you are attaching a Azure Container Registry. So we have created an Azure Container Registry in here. If you want to attach that particular Azure Container Registry, we can go ahead and give access like this path we have copied, the same path, the full path of this container registry we can give, so that if the Kubernetes or the AKS cluster needs access to any of the images, or if a user is coming and trying to download a image from that particular container registry, then your Kubernetes cluster should have access to get that particular image, otherwise it won't work. And then you enable monitoring, which enables log analytics. And you can also mention something parameter as a max pods, like how many pods you want to run. And as of now, it's a max you can give 250 with Azure CNI, and with Kubernetes, it's again a different figure, it's lesser. And enable autoscaler, which enables VMSS, and then autoscale functionality it will enable. And I will maintain a minimum of 3 nodes and maximum of 10 nodes, which means that I can even the auto scale kicks in, it would just can roll out a max of 10 nodes in a cluster. So let me go ahead into the resource group and check the status. Yes, my AKS cluster is getting created, and this is a non-RBAC cluster. And if I go through this, let me open a duplicate tab in here. So with AKS cluster, and basically an example of Databricks cluster as well, they create a secondary resource group named as MC_resource group. If you want to, and there only it would try to, because the resource group which we gave, it will have just the cluster, and at max it will have the log analytics workspace if we have given while creation. Okay, so if you go into the cluster, and then if we open, and you can type like MC_ something like this, or you can just paste in your resource cluster resource, or you can, what you can do is like you can paste, it should generate an MC_resource group. Let me find, refresh this. MC_. Let me see that resource in my subscription directly. Okay. I'll go to resource groups. Yeah, you can see this MC_resource groups, which is not a part of resource group which we have created. AKS cluster creates by its own this particular dependent resource group or secondary resource group, and dumps in all of the particular, the load balancer, what we've discussed, the VMSs, everything in here. Okay, if you go into the VMSs, virtual machine scale set, we can see our DS2v2 machines which we have spun instances which we running, and let's check the size. Okay, that's just check the instances. We'll see the number of instances are 3, which they started running as we mentioned. And then let's go back to our resource group. Let's see what other components have been provisioned. So since it's VMSs, the number of instances which are running are 3. Okay, in case what happens, like if we are not using all the 3 nodes, the VMSs take care of spinning down them from 3 to 1. So after a few moments, we will see that coming down because we didn't install any application as of now. And then we will, there's a public IP which is created because we are not using any on-premise VNet or something like that. And apart from that, for scaling, what you can do, so metrics, let me take you through the metrics which are very important. And yes, good insights. So these are the specific, you can see, like, let me load last 30 minutes. It just loaded up. So I want to see, I can make it live so that we can see the live metrics passing in for the cluster. But if this cluster is running long, then you will see all the metrics popping in, the node utilization, everything, and then onto the node what's happening, everything you can check. But before that, let's log into the cluster and just run some commands. Okay, for login to the cluster, since it's not an no, it's a non-RBAC cluster, so you will see this particular dashboard. I will go ahead and then I'll just uh, get credentials. I need to get my Cloud Shell running for this. Since I have just one subscription, so I can directly go and run this particular command, because it would have defaultly set this particular subscription. Let me try running it. So what it does is, like, it actually gets your configurations about or credentials or tokens of this particular cluster, and it sets into your kubeconfig. So kubeconfig is one particular file, like which you can see by this. You can come here, this is my Cloud Shell, right? And then you can see the AKS tag is the earlier cluster which we created. AKS tag is we created, and then we have certain token and other things which are visible. So you can give this to any developer so that they can directly using this kubeconfig, they can log into the cluster and then perform their activities. So that's a way how to log into the cluster. And how about checking the dashboard, how everything is running fine or not? I'll just copy this as a AKS browse and then paste it, and then I can go. So this is opening the dashboard is one particular simpler way of looking into what's happening inside your cluster. Sorry if we are extending by few minutes, just 5 more minutes, we'll be done. Yes, so now it's opens a proxy port, and then it opens the dashboard for us, the Kubernetes default dashboard. So it's asked me the kubeconfig or the token. So what I can do, the simplest way is go to the kubeconfig and open my kubeconfig quickly, and then copy the token to view the dashboard. But there are certain configurations which you can do to avoid this thing as well. I can sign in. So now I see my dashboards, complete dashboards have loaded up. So the namespaces are the logical separation, very similar to resource groups in Azure. So you can logically group your applications according to namespace. You can create namespace, but by default you have 3 namespaces. As part of the cluster creation, you will see they are all named with cube, and there is a default namespace which you have. So you can spin in the default namespaces, but you can't spin your own pods in this particular cube systems or cube public places. There are various varieties. We talked about replica sets. If we have some pods, we can see the replica pods, replica sets, everything. And what I can do is quickly go and let's close this editor and we open Cloud Shell. Let me open Cloud Shell here. So I just, since I'm running this dashboard, let's kill the dashboard by Control C, and I will just kubectl. So kubectl is a way to get the details of your cluster. So I'll just say kubectl get pods. Are there any pods which are running in my default namespace? And they are saying no, there's no pods which are running. And OK, let me check from other namespaces whether you are running anything. And let's see if, yeah, by default you can see a lot of pods are running. The OMS agent, which is used for log analytics, are running. The metric server is running. The kube proxy for networking, we had discussed, for virtual networking inside the node, is running. Since we have since we are running 3 nodes, so we have 3 pods. Since we have 3 proxy pods and 3 OMS agent nodes, and even 3 core DNS nodes. So it all depends, these particular pods will scale down, scale up according to the the auto scale or number of pods, number of nodes you have actually spun up in the initial. So in this was another thing, like we wanted to check the deployments, whether there are any deployments. For this, we just click up arrow key and then we can type deployments. So to see the deployment, since the pods are created using the deployments, right? So that's how it is. So if you want to delete these pods, I can go ahead and kubectl delete, as we were discussing last time. Delete deployments, and then you can give the deployment name as, since these are system, I don't want to tamper it. But how you can do is like you can provide the deployment name, and then you need to mention the namespace name specifically in case you want to delete this deployment kube system. And sorry for the spell mistake, delete. Okay, so this is how the pods, and you can also, one more thing, like you can look into the description of the particular deployments as we were discussing in the slides. I can describe, but for that I need to know the name of the deployment. I'll paste the deployment, I'll paste the name system namespace on which this pod is running, and then once we describe the deployment description, it would come like this, and you can see the description in here. So it says the CPU and memory, how much it is using, what is the namespace, and a few other parameters it would display. And you can also use something called as -u YAML. It will like -u YAML would work with kubectl get, which will describe your particular Kubernetes object in a YAML format. So this is what a YAML format would look like. And so quickly, let's go to the scale part. So how to manage the Kubernetes, this one scale, how you're going to scale the workloads. So one thing is like you can increase the capacity or the number of pods which you can create by increasing the number of nodes. Since we are using VM scale sets, we can directly go to VM scale set and we can increase it. Otherwise, what we can do is like we can use something called as Azure CNI for it, where you can allocate more number of max pods, can reach up to 250. Okay, so that's how you can scale your workloads. And scale out also works. Scale up will also work, where you need to go to your node pools and then you need to increase the size of your node pools. Like if you're using DS to V2, then you need to upgrade the size or scale the size from DS to V2 to any other. So you can increase the number of nodes for scale out, and for scale up, I will just go and upgrade. So in node pool, we can go to this particular virtual machine scale set directly, and then we can do it. So we have an MC_resource group. We can come here, and in VM scale set, you can go to the instances. Okay, and then these are the instances. You can choose which particular node pool you want to change. You can go to the size. You can go from there also, or you can come here. It would impact all of the node pools, and I can just go and decrease the scale down to B2S. In certain cases, this may fail because if your region doesn't have the B2S sizes, it would fail. Let's try with any other DS1 series. Let's resize. It's not happening, but yeah, that's what the the best way is to resize is like you come here and resize, and depending upon your subscription, your location, what you have selected, depending upon the availability, you will you can be able to resize so that you can fit your workloads accordingly. And in order to know more about if you want to know more about provisioning applications onto the AKS nodes, we'll update few of the commands in that in our repository itself, so that you can go through and let us know your feedback on it. Yeah, thank you from my end. Ashish, you can take over.
Yeah, thank you so much, Girish. It was echoing. Girish, can you please mute yourself?
Yeah.
Okay. Yeah. Thank you so much. It was really information. Who is else? Azure Talk. Okay. Yeah. So thank you so much, guys. We had some hiccups in terms of questionnaires and all. We will try to take care in the next session. We have a next session of this track next weekend. Again, Sunday, 7 p.m. Indian Standard Time. In the next session, we are going to cover the other compute resources, which will be part 2 of the same topic or agenda, I would say, or the same section, I would say, from the exam point of view. We will be covering about virtual machines, highly available virtual machine and all. So we will have a set of topics from the same section next weekend. And we'll be posting we have posted the self-paced learning lab links in the comment. So you can quickly go ahead, and if you want to kind of practice the things that we have discussed today, you can go ahead and practice it from the freely available Azure Learn resources. The beauty of these resources are like you get a free, free sandbox environment from the Microsoft. So that way you don't really have to worry about your own subscription and all those things. And about the questions, we might not have answered all the questions. So we'll recommend you guys to join our Telegram group and post your questions there. Post the event. We will try to answer all the questions over there as well. And if you have not registered for the another track that we are going with, AZ-900, we will request you to please go ahead and register for that as well. And again, we are already top of the time, so I will again thank you all for having the patience. Yeah, Neeraj.
Ashish, you're breaking up.
Yeah, Neeraj, please go ahead.
All right, so I want to thank once again we are on the top of the hour and we're really sorry we had to extend the session by 8 minutes. I really want to thank all the participants, all the audience, and for taking out time, especially on a weekend, especially on Sunday, to join our session today. And I want to take a couple of minutes to really thank all the speakers, Ashish, Girish and Vipin, and also our Azure Talk core team. Because of them, we are bringing it all because it's a community effort. All have come together to really contribute in every possible way. We'll keep doing these sessions, so just keep an eye, keep a watch, and we will be publishing these sessions, the recorded sessions, on our YouTube channel. So you can go and check out youtube.com/c/Azure Talk. There you can find all our recording. And also, you go to our website and register for future sessions. So we have another session, the third and the last session for AZ-900, which is lined up for next Saturday. And then we have a session, for AZ-104 on Sunday, 7 p.m. So please do head out to our website, azureaz.com/AZ-104 to register for AZ-104. And please do join our sessions in the next time. So once again, thank you everyone, and thanks for joining our session today. I wish you all have a great weekend, and I know it's tomorrow will be start office day. So have a great weekend, have a great weekday. Thank you, and thank you everyone. Good night, everyone.
Yeah, thanks. We will be uploading the session on our YouTube channel. So if you have not subscribed yet, please go ahead and subscribe, and we will be posting it. We will be sending email as well. Yeah, thank you. Thank you so much.
Thank you.